Let's find out orbital velocity of a satellite revolving around Earth. And we'll be assuming that its path is a perfect circle. Look here. This is Earth. Mass of Earth is m. A satellite is revolving at a distance of r, small r, from the center of Earth. Its mass is m. This is the circular orbit. Our aim is to find VO. VO for orbital velocity. Now, if you say that it's a perfect circle, then that means this satellite, it needs centripetal force, and that centripetal force is coming from the gravitational pull of Earth on this satellite. Now this is Earth. If you have something which is outside of a solid sphere, then you can consider all its mass at the center as a point. Listen again. If something is kept outside of Earth or outside of a solid sphere, then you can consider all its mass at the center as a point. And therefore, if Earth is placed at the center and this is your satellite, then gravitational force which is acting on the satellite will provide necessary centripetal force. This is the thing which will decide orbital velocity. Now, what is gravitational force? G m divided by r square. And what is centripetal force? Centripetal force, you know, is m v square divided by r. That's your VO. M and m cancelled, r square cancelled, and you get your orbital velocity as root over g m divided by r. The first thing which you notice is this orbital velocity is independent of mass of satellite. If it's m or 2m or 3m, it doesn't matter. Ultimately, m and m, they get cancelled. That means any mass which revolves at a distance of r, its orbital velocity is decided by the mass of Earth and distance of satellite from the center of Earth. If you consider that all the planets, they revolve in perfect circular paths, which they do not, because you know that these paths are what, elliptical. But if for the time being you assume that all the planets, they revolve about Sun in perfect circles, then in that case this m will be mass of Sun, and orbital velocity of a planet will be decided by its distance from the center of Sun and mass of Sun. Now, once you have found orbital velocity, you can see that it is a case of uniform circular motion. Why uniform circular motion? That force, this force is acting towards the center. That means its direction with velocity vector makes an angle of 90. If this is 90, there is no tangential force. All the gravitational force which Earth exerts on the satellite is providing centripetal force. There is no tangential force. F tangential is zero. Now, if F tangential is zero, that means we are discussing uniform. It implies that we are discussing uniform circular motion. In uniform circular motion, you know that speed, it doesn't change. Velocity, it does, because velocity means direction. But everywhere you go, speed of the satellite will be only what? VO. And therefore, next thing is we need to find time the satellite takes to complete one revolution. How do you find time? Time is found using this formula. Time is what? Distance divided by speed. When do we use time as distance upon speed? Only if speed is constant, which it is for this profile, and therefore total distance covered by the satellite is 2 pi r divided by its orbital speed, which is VO. This gives us 2 pi r divided by V, which is root over gm by r. Now, if you square on both sides and cancel the constant terms, you can see that this is coming t square proportional to r cube. Gm 2 pi, these are constants, r, and this is what? R to the power half. Jump, it becomes r to the power of t by 2 square, and you get t square proportional to what? R cube, which you know is called Kepler's third law. Now, when you say that t square is proportional to r cube, it means we took capital M as what? Constant, which means if all the satellites, they are revolving about same body, if all the Earth's satellite, you consider them, you can use this formula. You cannot use this formula for a satellite of Earth and a planet which is revolving about Sun, because in that case capital M is what? Different. What is capital M? Capital M is mass of that body about which all these things are moving. So if you say that this is Sun, then they are planets. If you say this is Earth, they all are what? Satellites of Earth. For a given body around which all the other satellites are revolving, you must use this formula, which is t square proportional to what? R cube. Now, this is your orbital velocity, this is your time. Next comes total energy of the satellite in its orbit. So, at this stage, pause the video. You have the concept of kinetic energy, you have the concept of potential energy, and therefore find out total mechanical energy of a satellite in its orbit. And then come back and see the solution. Now, if we need mechanical energy, then what is mechanical energy? Mechanical energy is kinetic energy plus potential energy. What is kinetic energy? What is kinetic energy? Half mv square, which is VO. Then what is potential energy? I told you that if you are outside, then you can consider Earth as a point mass at the center. Now, if you have 2 point masses separated by a distance of r, then their potential energy is given by minus of g m m divided by r. This is kinetic. This with negative sign is what? gravitational potential energy. Now you can see that this mv square, what is mv square? R and R cancel, mv square you can see is gmm upon r, or you can put value of VO. So you get what? gmm divided by r. mvo square. mvo square is what? R cancel, gmm divided by r, minus of gmm by r. gmm by r. This is minus of gmm divided by 2r. This is total mechanical energy of a satellite in its orbit, where orbital radius is r. Now, this gravitational potential energy, they can ask you a few objective questions on this part. What type of objective questions they can ask you? Look here. They will ask you that total energy is K. Total energy is P. Total energy is P divided by 2. Potential energy divided by 2. Total energy is minus of kinetic energy. Now, first, total energy, that is total mechanical energy. Total mechanical energy, can it be equal to kinetic energy? Answer is no, because total mechanical energy is what? Sum of K and P. That means first two options are wrong. So now look at the third option. Third option says total energy is half of potential energy. What is potential energy? Minus of gmm by r, this much only. And what is total energy? Minus of gmm by 2r, which is what? Half of potential energy. And therefore, this third option is the correct option. Now, look at the fourth one. What is kinetic energy? Kinetic energy is half mvo square. What is that? Half of gmm by r. But what is potential energy? What is total energy? Minus of gmm by 2r. That means if you put a negative sign in front of this, then it gives you what? Total energy. And therefore, this fourth option is also correct option. So that's how you calculate what? Orbital velocity, time period, total mechanical energy in terms of kinetic and potential energy, and an objective profile in this form. Note down everything. Now let's see escape velocity. What is escape velocity? Write down the statement. Minimum velocity on the surface of Earth, minimum velocity on the surface of Earth with which a projectile should be projected so that it doesn't come back and fall on the surface of Earth. So that it doesn't come back and fall on the surface of Earth. When you say that something doesn't come back and falls down on the surface of Earth, that means it has moved to a region where there is no gravity. And that place is what? That place is at infinity. So, This is Earth. Its mass is m. That's your projectile. And we are projecting it with VE, which is escape velocity. And when you project it with VE, it moves to infinity. And at infinity, gravitational pull of Earth on this projectile will become what? Zero, and therefore it cannot come back. Mass of projectile is m. Why do we say that? V is minimum. Suppose V is 10. Now when you throw this thing, this projectile with 10, it reaches infinity and it cannot come back. If you throw it with 9, it will be somewhere here. That means at a place where gravitational force of Earth is present, and therefore Earth will pull it back towards itself. So when you give it 10, it reaches this position. When you give it 9, it reaches this position and comes back. But if you give it 11, what will happen? If you give it 11, it will cross infinity. Now once it has crossed infinity, again there is no way it can come back. If you give it 12, again it will cross infinity, it will not come back. So what was the minimum so that it cannot come back? That minimum is what? 10. We are interested in finding this minimum velocity. So minimum velocity with which you should throw something from the surface of Earth so that it doesn't come back is called what? Escape velocity. Now, how do you handle a question like this? Once you project it, it's gone out of your hand. W external is 0. There is no external work. Once I throw this thing, once it leaves my hand, the moment it leaves my hand, W external becomes what? 0. And if W external is 0, you know that we use COME. Now pause the video and try to find escape velocity using concept of conservation of mechanical energy. So you can see that distance from the center of Earth of this projectile is r. What is kinetic energy initial? When you use COME, it means kinetic energy initial, potential energy initial, which is gravitational potential energy, kinetic energy final, plus potential energy final. What is initial kinetic energy? Half mv e square. What is gravitational potential energy? If you're outside, then you know that if you're outside of solid sphere, then total mass of solid sphere is considered at the center, which means for this profile, Earth is at the center. That's your projectile. Distance between these 2 points is r, and that gives you potential energy as minus of gmm divided by r. Finally, when you reach infinity, since v is minimum, just when you reach infinity, your velocity becomes 0. At infinity, your velocity becomes 0. That means final kinetic energy is what? Zero. And when you are at infinity, you know that potential energy is taken at infinity as what? Zero. This gives you V, M cancelled, and your V is coming root over 2 G M divided by R. Root over 2 GM divided by R. Now you know that if something is on the Earth's surface, M, then gravitational pull of Earth on this object is G M divided by R square, which you know is called mg naught. What is G naught? Strength of gravitational field, the surface of Earth. From this, you can see that this, let's first make small r, capital R. This is capital R. So what's the value of Gm divided by R? From here, you can see that Gm divided by R is coming G naught multiplied by R. M cancel, Gm divided by R. Gm divided by R is coming G naught into R. If you put it here, it gives you root over 2 times G naught into R. If you take G on the surface of Earth as 10, then this is 2 into 10. Earth's radius is 6,400 kilometers. That is 6,400 into 10 to the power 3. When you simplify everything, it comes as 11.2 kilometers per second. This is 6,400 kilometers converted in meters. That's your G in meters per second square. And when you solve this thing, you will get an approximate value of 11.2 kilometers per second. That means if you throw something from the surface of Earth with the speed of 11.2 kilometers per second, then it will never come back. It will reach to infinity. Now, if I ask you that we have thrown a mass of 1 kg, or in the next case we have to throw a mass of 100 kg, for which one escape velocity will be more? Then some people think that for 100 kg escape velocity will be more, but that's not the case. Look here, you can see that M and M, these are getting cancelled, and ultimately you're left with what? Gm divided by R. Gm divided by R, where M is what? Mass of this Earth, or mass of a planet from which you're throwing an object with escape velocity. So you can see for Earth it is coming 11.2 kilometers per second. It has nothing to do with the mass of projectile being thrown. Now, this is regarding escape velocity, its magnitude. But what if you throw something at an angle of 45 degrees? If I throw a projectile at an angle of 45 degrees, and then if I ask you what will be the escape velocity, then put on this as a question. A projectile is being fired at an angle of 45 degrees from the surface of Earth. Find out its escape velocity. Pause the video, try to find an answer for this, come back and see the solution. Now, if you throw this projectile at an angle of 45 degrees, then again you will be using what? COME. That means what? you'll be using kinetic energy. What is kinetic energy? Is it a vector? No, it's a scalar quantity, and therefore you throw something up or you throw it at some angle, kinetic energy will be always what? Half mv square. And every time since you throw it from the surface of Earth, potential energy will be what? Minus of gmm divided by r. And once these things they reach infinity, gravitational potential energy becomes what? Zero, and kinetic energy becomes what? Zero. And therefore, it doesn't matter at what angle you project your projectile, ultimately, escape velocity is what? 11.2 kilometers per second. That means escape velocity, it doesn't depend upon mass of projectile as well as its direction of projection. Write down this modified statement. Escape velocity does not depend upon mass of the projectile as well as its direction of projection. And therefore this V is also same. There is no change in it. Note down this much. Now let's take some examples on escape velocity. We have a circular ring of mass m. From the center of the circular ring, a point mass m is projected along the axis with escape velocity v. This ring is fixed, it doesn't move. Ring is fixed, its radius is r. From its center, you throw an object, a point mass with speed v. The question is find out v, escape velocity, so that it doesn't come back and reach the center of ring again. Pause the video, try to find an answer, come back and see the solution. Now, the moment you say you have projected something, once it is out of your hand, W external is 0, and therefore you will use COME. What is COME? Kinetic energy initial plus potential energy initial, kinetic energy final plus potential energy final. Kinetic energy you can see is what? Half mv. What is potential energy? Now, it's a ring. You cannot place a ring at its center as a point if you need potential energy. For Earth, what we did, we placed the whole mass at the center. But you cannot do that with ring. So remember, this concept of placing the whole mass at the center is valid only for a solid or a hollow sphere, and that too if you are outside of this sphere. Now, you have a point mass at the center. What is the distance of this point mass from the entire circular ring? R. And therefore, potential energy is what? Minus of Gmm divided by R. We've already done an example, and therefore you know this thing. So when you place a point mass at the center, potential energy of point mass with this ring is minus of gmm by r. Once it reaches infinity, what is kinetic energy? Zero. What is potential energy? Zero. Again, VE is coming what? Root over 2 gm divided by r. But remember, this is not 11.2 kilometers per second because this is a circular ring. That 11.2 kilometers per second is only if you have something which you throw from the surface of Earth. Note down this and then try to answer this next question. We saw that, and if you have a satellite and it is moving around Earth in a circular orbit of radius r, its orbital velocity was VO. And this VO, if you remember, it was root over gm divided by r. That was the orbital velocity of the satellite, small m, around Earth of mass m. The question is, with what factor one must increase orbital velocity so that this satellite can escape to infinity? Write down the question. With what factor orbital velocity of a satellite should be increased? With what factor orbital velocity of a satellite should be increased so that it escapes to infinity? It escapes to infinity. I mean, that means it's no longer in the circular orbit. You changed its speed from VO to VE. For circular orbit, speed is what? VO. But what you did, you gave it some velocity VE and then it goes to infinity. The aim is to find VE in terms of VO. Pause the video, try to answer this question. Every question of this type is always solved with the help of COME. And therefore, let's use the same calculation part. What is kinetic energy? Half mv square. What is potential energy initially? Initially, from the center of Earth, satellite is at a distance of r. Small r is from the center. From the center, distance is r, and therefore gravitational potential energy is what? Minus of gmm divided by r. And when it reaches infinity, they both become what? Zero. That gives you what? V, which is coming as root over 2 gm by r. That's your escape velocity for this satellite. But I've asked you by what factor it must be increased. Orbital velocity. What is VO? Root gm by r. And what is escape velocity coming? Root over 2 gm by r, which means this gm by r under the root is VO, and therefore it gives you root 2 times VO. Root 2 times VO. That means you must increase orbital velocity by a factor of root 2. They also ask this question in terms of percentage. By what percentage orbital velocity should be increased? Write down the same question in this form also. Find out by what percentage velocity of a satellite should be increased. Find out by what percentage velocity of a satellite should be increased in its orbit so that it escapes to infinity. So, you found the value of scale velocity for percentage change. Always remember a simple formula for percentage change. And this formula is what? Final minus initial divided by initial into 100. Final quantity minus initial quantity divided by initial quantity into 100. What's your final? Root 2 times VO. What is initial? Initially it was moving with VO divided by VO multiplied by 100. VO cancel. What is root 2? 1.414 minus 1, that is 0.414 multiplied by 100 is coming 41.4%. So if you increase orbital velocity by a percentage of 41.4%, then this satellite will skate to infinity. Note down this much.